time for the famous free fall object. As long as you are near the surface of the Earth, which we are because we're not in outer space, objects will fall at a given rate of gravitational constant. Boom. Notice, let's grab that again. Please take a look. Object will fall because of gravity. Right? This can be described mathematically. Right? This is what we have. Formula. Okay. The distance that it will fall is equal to 1/2 of g, which is the gravitational constant, times the number of seconds that it's falling squared. Okay, now let's take a look over here. G, as I just said, is the acceleration due to gravity. Now this is near the Earth's surface. This is going to be a different constant on different celestial bodies, but if we're on Earth, it's going to be 9.8 meters per second squared. All right, so that's the gravitational constant. The t is going to stand for time in seconds, and as we said, the d is the distance that the object falls. Now this is a free fall. All right, this is not being impeded by any other forces. It's just free fall. All right, so let's come over here, and let's say we were dropping our object into an enormous pit, and it was going and going and going and going for 10 seconds. Let's see how far the object would fall. All right, so we've got an evaluated expression to do this. We're going to plug 10 in for t, and we will put our gravitational constant of 9.8 meters per second squared in for g. So we're going to do that substitution step. So the distance the object will fall will be 1/2 times our g, which is 9.8 meters per second squared, times 10 seconds, and of course that's going to be squared because it's t to the second power. All right, now let's take a look here. We know from the order of operations that we have to do the exponent before we do the multiplication, and that's all we have here is just multiplication and exponent. So let's see. We're going to get distance is equal to 1/2 times 9.8 meters per second squared. Now we have to square this. If we square the 100, we will get, or excuse me, if we square the 10, we'll get 100. And if we square the seconds, we'll get seconds squared. Okay. Now, notice what's going to happen here. The units will cancel, by George. Seconds squared, and that's going to leave us with meters, which is a distance unit. So the numbers are really kind of working out well here. So we're going to get distance is equal to, okay, now multiplication is commutative, so we can do this however we like. We can take half of 9.8 and then times 100, or half of 100, get 50 times 9.8, doesn't really matter. Half of 9.8 is what, 4.9? Yeah. Okay, so 4.9 times 100 is 490, and that's going to be meters.
Yo, it's Math Mix-Up. Everybody's math. Gotta love the teacher. You happy?